Can everyone hear me? Okay. So welcome to Loading, a deep dive into website and web app performance. Let's start off with a little about me. I started I'm self-taught, so I always started with wanting to solve unique or curious problems. And the first problem I ran into was in grade 7. Our school board blocked Miniclip. So I wanted to play video games and went home, looked up how to build a website, put the games on there, and that's how I started in web development. Now, it was also the day I found out CSS and I will be mortal enemies, but that's a topic for another day. Now, I like to tinker with things, and I like to tinker with them until they break. Usually that ends up in a little bit of a panic, but I fix 80% of the things I break. My personal site is called drunkenstory.com. It does have a story behind it, but it is my personal portfolio site if you want to check it out at some point. Now, let's get into what we're discussing tonight. Our discussion tonight is going to be 3 main sections. There's going to be a brief intro to what performance is when it comes to the web, metrics and key measurements and how you make those measurements. And finally, some general optimization and tips on how to improve things. It's a bit hard to go into specifics without knowing your tech stack. So general is the best I can do. So let's start with what is performance in terms of the web. It's, in my opinion, made up of 3 main things. It's raw speed, how responsive the site is, and how efficient the code you're delivering to the user is. So why does this matter? And let's start that off with what speed of convenience is. All your users are moving at what is called the speed of convenience. What is it? It's the pace at which we navigate the internet. It's dictated by the capabilities of the device or medium through which we access it. Now, a quick question to the audience. You can shout out the answer if you know it. Do you know who this quote is attributed to? Anyone? No? Me. So it's what I've called I've called it speed of convenience since about 2016, and it's a great way to basically explain how you cater to your users. If you want to learn more about it, there is an article that you can scan and go to. It basically explains a bit of the speed of convenience and how performance should be dictated by it. And moving on. So I'm going to have a question to you guys, and this is just to see, one, how well you guys know how much performance impacts whatever application or service you work for, and 2, to give you an idea of why performance matters. So the question is, a site that loads in 1 second has a conversion rate that is X% higher than a site that loads in 5 seconds. Any guesses? Okay, pretty good answers. The right answer is 300%. So you guys were in between. But think about that. 4 seconds is the difference between a 300% increase in conversions, which it's not an insignificant amount. Now, the other thing I want to kind of bring to your attention is a lot of you are probably taught that, a fast site is needed for search engine optimization. But most of you are told that it's based on the metrics for your page speed. That's actually a myth. What it's based on is how much your users bounce back to Google within the first 20 seconds. This has been extensively tested by me in the past few years, and I'm using data to back up this conclusion. Okay, so let's get into a few metrics and why metrics matter. So metrics are your bread and butter. Without them, you have no actionable data. What do I mean by that? Well, I've actually met a few devs who just rely on visual feedback and their gut to figure out if their site's fast. That's not the way to do it. You need a baseline metric. You need something that you can compare to so you know if you've actually made measurable improvement versus just relying on your gut for something like that. I generally categorize the metrics into two things because it makes life easier in the long run. I call them general metrics and then user-centric metrics. We're going to start off with the general metrics. There are three main ones. There's a lot of additional smaller ones. If I try fitting them in, this will turn into a 3-hour lecture, so we're not doing that. The three main ones are load time, TTFB, or time to first byte, and the speed index. Let's start with load time. Prior to 2018, this used to be the metric that defined performance for a website. The problem with this is that it does not take the user experience between whatever time it is to load into account. And if you look at the GIF on the right side, arguably in low quality because it is from 2018, it shows you the problem. All the content is randomly moving about as things are loading in. The layout shifts, the font changes. It's an annoying experience for the user. Now, the ideal target for this, because it still matters, is about 2 to 2.5 seconds. And on all devices, there is an asterisk to this, and that's mainly, it is still reliant on the network conditions. So I'm talking about an ideal network where 2 to 2.5 seconds count. Now, the probability of a bounce increases to 32% when you go from 2 to 3 seconds, and it increases to 90% at 5 seconds. Basically, 2 seconds, and you're going to lose 90% of your users. Think about that. The next one is time to first byte. This is the total time it takes for the first byte of data to respond back to any request that you've made. This is made up of a few things: the request start, the DNS lookup, the SSL negotiation time, the initial connection, and the rather confusingly named time to first byte. The time to first byte highlighted in the image is actually the time that your server takes to respond to a request. The reason this is broken down into these individual sections is very simple. It's so that you can kind of diagnose where the slowdown is actually happening. And if it's above 200 milliseconds, you have a problem that you need to fix. Above that, it actually hinders a user's experience. The last one is speed index. It doesn't matter as much anymore because there are other metrics that will be coming up later that kind of do the same thing. It's the time it takes for a page to look complete. The main reason this exists is it's purely visual, and the lower the score, the faster it feels to the user. And recommendations vary all the way up to 2.5 seconds. You shouldn't actually be over 1.2 seconds. In reality, if you want to claim you have a fast site, it should be 800 milliseconds. Just saying. So to give you an idea of why the three metrics I just mentioned matter, I want to give you an example of raw performance in action. So zebrablinds.com, my former employer, saw a 22% increase from reducing our pure loading time from 3.5 seconds to 2.2 seconds. That's all we did. We just reduced the loading time by 1 second and just magically saw a 22% increase in conversions. That's not a small amount. Now, let's get into what perceived performance is. And I feel like this is one of the things that a lot of people don't focus on when it comes to performance. Raw performance is needed, but it's a fool's errand if that's the only thing you're looking at. Because raw performance is also dictated by physics. There's only a certain amount of data you can push through at this, like in one moment. So perceived performance. It's basically starting to take feelings into consideration. It's how fast a page feels to a user regardless of raw performance. So technically it's fine if your site takes 5 seconds to load as long as you convince the user that it's not. It's human psychology 101. If you sprinkle a little bit of magic that shows them there's some speed and that is responsive within the first second or so, you get satisfied and engaged users. Makes a little bit of sense. Now, it's heavily influenced by visual cues and the order content renders. And this is where user metrics come into play. But like all magic tricks, if it's done wrong, well, you have this. So what are these metrics? The 5 big ones are CLS, FCP, LCP, TTI, and TBT. I'll go into detail on each one. So CLS is called the cumulative layout shift, and this measures the unexpected movement of visual elements in a page view. It keeps track of the largest burst of layout shifts within a 5-second period with no more than a second in between. This is usually because it's the easiest way to find out what's most annoying within the first 5 seconds of a page load to a user. The ideal score is less than 0.1. This is not based on seconds. This is based on a formula, which is layout shift equals the impact fraction multiplied by the distance fraction. What are those? Well, if you take a look at this image, you can see 2 frames. One is before the shift, and the next one is after the shift. To calculate an impact fraction, you look at the total amount that within the page view or the viewport that the change is affecting. And in this case, that's about 75% of the viewport. So that is your impact fraction. It's 0.75 or 3/4. The distance fraction is how far along the viewport the content moved relative to its original position. So in this case, it's approximately 25%, so 0.25. If you multiply both together, you get an answer of 0.1875, which means this site sucks and it fails. So the next one is FCP, or first contentful paint. It's very simple. It's the time taken to render the initial DOM content. This is very important. You're basically indicating to your user that something's happening and they're not staring at just a blank screen. Now, a good score is considered 1.8 seconds. This is way too high. Ideally, you should be below 1 second. You should actually be around 400 milliseconds. Anything above 500 milliseconds is far too long. And you can see an example of what I mean by FCP. The first frame in the example image is blank. The second one just shows the header of Google search, which is their FCP. And the last one is the entire page loading. Now, the next metric is related to FCP, and it's called the largest contentful paint. It's basically the time taken for the largest visual change, such as an image or text, to be rendered. And this provides the best visual cue for someone that your page is actually ready to use. It's a very important metric, and a good score is usually 2.5 seconds or less. The fastest sites I've seen are 800 milliseconds usually. I've seen a few that are a bit lower, but you can't really do it multiple times. This is an example which shows, kind of illustrates the difference between the FCP and the LCP. But it gives you an idea, especially in the last frame, since the image is the last element that loaded, it's the one of significant importance. So the next one is time to interactive. So this one's a bit interesting. It's how long a page takes to load and be responsive to clicks and taps with no visible freezing or input delays or things of that nature. It's measured after the FCP and what's known as a quiet window. What is the quiet window? Well, if you look at the image on the right side, you can see this highlighted area that's like a slight gray. So it's the period after any instances of the CPU thread or the main CPU thread being used for more than 50 milliseconds. and there's basically a 5-second window with no 2 in-flight GET requests. What is an in-flight GET request? It's basically any request that your browser's already made to fetch resources, and they're basically in the process of being downloaded and not being initiated. The reason it matters is, once again, it comes down to responsiveness. If this metric is high, that means your site's having micro stutters and input delays all along the way. The last one is TBT, or total blocking time. It's related to time to interactive, and it's very simple. It adds up all the instances where the main CPU thread was used for more than 50 milliseconds. And that's it. It does it until TTI is identified. This is a very good indication if your page froze or wasn't responding to a user's input for a certain amount of time. A good score is 200 milliseconds, but if you think about it, if the score is about 400 milliseconds, it means your site was unresponsive for half a second. That affects a user's experience. Now let's look at a little example of perceived performance in action. I'm pretty sure all of you are aware of a company called Pinterest. Well, they reduced their perceived wait times by 40%, and this increased search engine traffic and signups by 15%. Now, 15% doesn't sound like a huge amount, but let me put that into perspective. That's 165 million visits a month, to give you an idea. So how do we measure them? There are two ways. The first one is what I like to call synthetic measurement tools. What is synthetic measurement? Basically just testing under simulated network and device conditions. I would love to give you a demo of this, but once again, this would change into a lecture, so I'm not. The two tools I do recommend, though, are Lighthouse and Web Page Test by Catchpoint. Lighthouse is heavily supported by Google, and it's available in Google PageSpeed Insights, Chrome DevTools, as a Chrome extension, and as well as a Node CLI and a Node module. This is important because you can actually implement it as an automated testing integration into your deployment pipeline. Web Page Test by Catchpoint is Lighthouse on steroids. It gives you way more actionable data to fine-tune what you're looking at. It also has something called a playground, which lets you test things without actually implementing them on your site. Now, I don't know about you guys, but when it comes to alcohol, I prefer rum. But also when it comes to, metrics, I also prefer rum. It's real user monitoring. You're capturing a subset of real user data, because what's better than actually knowing what your users are experiencing? Now, common tools for this, New Relic, Datadog, and a shout out to Sentry, because Lazar's here. And alternatively, you can make your own script. I don't recommend this because the existing tools actually do a really good job, and you're not going to get anywhere close to that. You don't want to do this on all your data because you are adding a small performance overhead. Now, the one thing I want to stress here is data analytics is cumbersome. It's not, there's a lot more to it than what I just showed you. There's a lot more metrics, and the ones I showed you are just a subset. But data is what gives you the first step towards optimizing for performance. If you don't have data, you don't know what to do. Another thing you should always be doing is implementing continuous automated monitoring and testing, because regressions are guaranteed to happen. One way to do it is to use Selenium. The reason I recommend this is now you can do custom metrics. For example, at Zebra Blinds, one of our more important metrics was how long it took a returning user to log into their account, go into their shopping cart that was already preloaded with at least 50 items, input their details, and check out and finalize the order. We scripted that in Selenium, and we hooked it up into AWS CloudWatch, so it would trigger using Lambda, and essentially we had it running under different conditions: high CPU load, high memory usage, high I/O usage, high database queries. So we could run it under different conditions and make sure our basic requirements and thresholds are being met. I haven't found enough companies actually doing this approach, and this is highly recommended to do. Now let's get into some common optimization practices. And as I mentioned before, simply because of the various differences in tech stacks, I can't go over everything. I'm going over some of the more generalized things that I'm hoping some of you don't know, some of you may know. But the first thing you want to do is create a performance budget. You want to establish what your baselines are. You want to establish where you want to get to. The second thing you want to do is compare it with industry standards and your niche standards. What is a niche standard? Well, imagine I'm selling an apple. I'll go on Google and I will search for how to buy an apple. The first 10 sites that show up, I will go open up their sites and benchmark them. You've now set your niche standard. Work in baby steps. Make it incremental. Don't do large steps, because large steps are the way to create further problems with incompatibility and other issues down the line. And your goal should be better than the industry standard. Don't follow other people. It's the bad way to go about it. First thing should be straightforward to most people here: CDNs, content delivery networks, quick and easy way to decrease your load time in general. If it's possible, take it a step further, deploy your code closer to people, but that also depends on your monetary budget. Ooh, wrong one. And then the next one is the difference between HTTP2 and HTTP3 protocols. HTTP2 introduced multiplexing and server push. HTTP3 fixes multiplexing issues with HTTP2. To give you an idea of what it is, multiplexing is when your browser can make multiple requests for resources and then download it all in one go. The problem with HTTP2 though is the download happens in a single stream. So if you're in a network with very high latency, or you have high levels of buffer bloat, I'm looking at you, Rogers, what essentially ends up happening is the entire data stream gets stopped. An example of this is when you try loading a website. If it's looking like it's loading and doing nothing, but you hit reload and it loads instantly, that's what's happening. HTTP3 fixes this, and you only lose the specific data that's lost, not the entire thing. 36% of sites currently use HTTP2, 25% use HTTP3, and this is as of the beginning of September. To give you a frame of reference, in January, 60% of sites used HTTP2 and HTTP3 was at 1%. So if you're working somewhere and you're not on HTTP3, hop on board, please. The next one is excessive library dependencies and code splitting. For this, take a lesson from our dear friend Homer Simpson. You must jettison excess weight. Always check what dependencies you're loading, because as you start adding various different libraries to make your life easier, you stop realizing you're adding way more dependencies along with it. You can very quickly go from less than a megabyte of JavaScript to very easily over 4 megabytes. I have seen one site before that had 8, and they didn't realize it. Now, Next.js has code splitting built in if you use it, but it is also possible to do it manually. But you ideally don't want to get into a situation where you have to absolutely rely on code splitting. I still recommend using it even if your library is smaller. It's just you shouldn't be using it to fix a crutch of extensive dependencies. The other one I like to go over, which I realize some people don't actually know well enough, is preload, async, and defer. adding the attribute rel equals preload allows you to preload assets such as web fonts, JavaScript files, style sheets. The benefit with this is it might load about 100 or 200 milliseconds faster than you would do it normally. Excuse me. And if you limit it to just above the fold content, usually it means you get a lightning fast website loading, at least to the user. Async basically downloads JavaScript files while parsing is still happening. The only difference is it executes it as soon as the file is downloaded. Normally, when you just declare a JavaScript file or a CSS file, your browser first downloads it, tries to figure out if it can execute it, and then keeps going. Async changes that. Then the next one that comes along with async, which does a similar thing, is defer. It also downloads JS and other files while parsing the page, but it only fires the files or the script before the DOM content loaded event on your browser. So why would we choose async or defer? Async is ideally suited for stuff like analytics, website chats, and things like that. And the reason for that is it is actually running at a slightly deprioritized connection, which is the first issue. And the second issue is it doesn't download the code or the scripts in the order it actually starts downloading them. It will just fire whichever is done. Defer maintains the order. That way, if your code is actually dependent on earlier parts that need downloading, well, it can do that now. Then one I like to stress on is images and skeleton screens. It's kind of basic. Most of you should know this. Use lazy loading on below the fold. For above the fold, try not to, because you do want that instant response. Try to use lossy image compression if possible. If not, use lossy image compression and then replace the image as the user is actually using the site, and use faster rendering image standards such as WebP. Now, I do want to go on a little side tangent here. For anyone here who likes to manage their own updates to things, when you go home, please update your browsers and your password managers. Last week, there is a WebP related memory overflow bug, which is identified as being exploited in the wild. So back to this. The next thing you want to consider using is skeleton screens, and you can see that on the right end. Ideally, don't exceed 1 to 2 seconds. Don't be LinkedIn and give you 5 seconds of this crap, please. But yeah, skeleton screens. And the last one I like to go over is caching. It's a very powerful tool when it's used right. And what I mean by that is a lot of people, and I mean a lot, like to slap on a cache in front of unoptimized code. What you're essentially doing is the same thing that our little buddy on the screen is doing. You're trying to block or hide away holes, and when it does implode, now you'll be at a significantly worse situation than you should be. So why would you cache? Well, reduces resource usage, especially in high load conditions. It helps reduce some server costs if you're a part of the DevOps team or related to the budget side of things. Helps with metrics such as TTFB. And you can do caching at many layers, at the browser, application, database, specific components, even in like code layers in some cases. Now, the takeaway that I want you to take from all of this is that there is no one size fits all when it comes to web optimization. It's always a moving target. It's not something that you do once and you let go. It's something that has to be constantly done. It has to be something that's constantly integrated into your deployment pipeline. And it's something that you should be prioritizing if you're serving content to your everyday consumer. You need to identify your user speed of convenience and then optimize your services to meet it. It's not on the user to like your service. It's on you to capture them and engage them. and keep them going so they actually use it. That is actually it for my talk for the night. I know I didn't go a lot into backend, and it's a bit difficult once again because of all the different tech stacks out there. But yeah, that's really it. Thank you. I'm also putting a shameless plug because I am open to new roles and opportunities, and you can text me to get in touch. So, any questions? Yeah.
So you mentioned about HTTP 2 and 3.
Yeah.
And what's the best way to check if you're using that protocol?
So the question is, what's the best way to check if you're using HTTP 2 or HTTP 3? Easiest way, open up, if you're using Chrome DevTools, if not Firefox, go into the network tab and just reload the page. If your first response and all preceding responses have HTTP 2, I believe it usually shows up under one of the sub tabs. I don't remember the exact name. You'll know. It shows you the protocol right there. Any other questions? Yeah, go for it.
So you mentioned the fold element, fold image.
Yeah.
Yeah. I don't know what it is.
Oh, above the fold? Okay, so the question is, what is above the fold and below the fold? Above the fold is basically referring to the initial viewport that a user would see. Below the fold is everything below the viewport, and that's things that you can try and deprioritize a bit and try loading in as the user gets to, essentially. Any other questions? Yes. So it's for all, it actually affects all browsers, including Safari. It also affects all Electron-based apps. Oh, the question was if the memory overflow bug I mentioned with WebP affects all browsers. So yes, it does. It also affects all Electron-based applications, such as 1Password, Bitwarden, a couple others. And also some mail clients like MailSpring and a few others. That's where it gets dangerous because your mail loads in an image, it has the exploit on it, you're kind of screwed. Any other questions? Yeah. Okay, so the question is, in the slide where I mentioned that it's the time that it takes a user to bounce back to Google that defines how well their site actually does for SEO versus the metrics themselves. How did I measure it? It was actually a long and slightly drawn out process. We had to do it over a couple months where we straight up just deployed multiple sites under different niches and industries, kept our IPs as separate as possible, used basically the Tor browser. We basically went all out to make sure Google couldn't fingerprint us with it. And essentially what we found was, depending on the niche you're in, the percentage does matter, or I mean, not the percentage, the time, the bounce time does matter. So it varies depending on the niche, but normally the average is about 20 seconds. If a Google clicks in, or if a user clicks in from Google to your site and they bounce back within the first 20 seconds, it basically is giving Google a signal that you're not relevant to that search term. If it happens enough times, you basically start falling on the rankings. And it's very easy to recreate if you have the right tools and time. It's not something you can do over a month. It's something you have to take about 6 months of preparation, focusing on SEOing that site, bringing it up, and then testing it for the sole purpose of ruining it and gathering metrics. Yes.
What's your takes to not having users bounce back to Google?
The simplest is you want to keep them as engaged with your site as possible. The most common mistakes that people make when it comes to this is you think the user is coming to your service because they like the service or it's a service that they need. The thing you want to keep in mind is as soon as a competitor comes up, if there isn't one, that's even just half a second faster than you, that experience adds up. And by half a second, it can be perceived performance, it can be the actual load time, it can be a number of different factors. But as soon as that happens, they will switch over because all that time does add up. And think about the speed of convenience. How often have you guys clicked on something on your phone, on your laptops, and it took just an extra half second to load, and you're like, I hate my life right now, right? And that matters. As web devs, I feel like a lot of us put that focus towards the very end of things where we're optimizing for things after it's built. And it's a way to do it, but it's an annoying way to do it. You should ideally be implementing all the tests and checking if all of this makes sense, at least at a baseline level, and then deploying it and gathering more data. Remember, data is your friend. Any other questions? You had one, right? Okay, so the question is, what is code splitting and how it affects bundle size? So code splitting is basically splitting your JavaScript code into multiple bundles. So for example, if your top of the page only requires 60 KB of JavaScript, that'll be a separate file. If the bottom of the page requires 200 KB, that'll be a separate file. That way you can prioritize and deprioritize different parts as it's needed, essentially. Your focus should always be for the initial top of the page content or above the fold content, because that's what defines a user's initial experience. And if you can't bring them in on that initial experience, you're going to lose them. Anything else? Yes. Yes. Okay. So the question is which of the metrics, especially the user-centric metrics, that you should prioritize first. The first one is probably FCP, followed by CLS. So first contentful paint, cumulative layout shift, and then your largest contentful paint, and then everything else. The reason for this, and my reasoning behind this, is those are usually the three things that define the annoyance level for a user. If you wait more than 2 seconds before something's visible, you have a problem. If a user feels that the site didn't load within 2 seconds, you have a problem. And the CLS is the parts in between. They'll probably start at least at the very least scrolling on the page. If you're having random layout shifts while that's happening, you have a problem. That said, one thing I do want to point out, because I just realized I didn't say this, scrolling doesn't count as your site being responsive. Scrolling runs on a secondary CPU thread. So it has its own dedicated thing to move the page around. Responsiveness is down to, does elements on the page work if you click on it? Can you actually type on something? Or if there's a rotating banner, can you move it? And things like that. Any? Yes. So I focused a bit more on the absolute basics, just because I didn't know exactly what kind of audience we'd be getting, as well as if I went into service workers and everything else, we could be talking on this for hours. We can chat after this about it. Yes. So I don't have enough experience with it to comment. Even though I know a lot of those metrics, I'm primarily actually a backend dev as well as a DevOps person. It's just in my previous role, I was still the one in charge of conversion optimization and performance in general. That said, there are a few people that I can introduce to you after this that will know about that subject. Yes, him. Yes. Yes, I have. I I find that it's it's effective, but I find like you find the random odd case where it doesn't work like it should. So I still prefer to recommend WebP over anything else. Anything else or anyone else? Yes. Pardon? Yeah. So the question is, when it comes to like bundle size and things, because of tree shaking or and related things, you're technically not importing all of it. Well, that is true, but the talk is also not specifically for React or other code bases that might be doing that. It is a bit more generalized. So in web in general, there's plenty of other systems and frameworks that are in use. And one I had the absolute displeasure of working with the last couple of years was called Magento 2. If any of you are ever considering it, run away, please. Um, any other questions? Yes. So design changes are also actually up there. The main difference though is that um, you would be approaching it in a way. Uh, you would be approaching it with the initial context with whoever your front end dev is to work on this. But in the grand scheme of things, you'd kind of have to figure out what your aim for the user experience is for that initial load, and then design around that, and then see if the web dev can also implement what your vision for it is. Um, it's a murky area because not everything is possible, but you try and push it as far as you can go. Anything else? Yep. So the question is, if it's between mobile and desktop, do the metrics basically vary slightly, or are there different metrics? The main metrics are still the same. For the subset of metrics that when you do your own research, some will become a bit more important than others. But in the grand scheme of things, the times and stuff you're aiming for is still about the same. The times and the scores. And the reason for it is it's based on whatever the current general speed is. So in North America, for example, right now the average internet speed is about 100 Mbps. So almost every modern device can utilize that at its max. And then if you're using something like, the last 3 generations of iPhone, which uses the same chip that's in your Mac, it can render those pages very quickly. So you only have 1 to 2 seconds to do all of this and optimize it for that person's experience. So the metrics will pretty much stay the same. The only time you want to look at changing it is if you're, catering to situations where there's high network latency or low internet speeds in general. That said, average internet speeds across the world right now is 25 Mbps. So, we done? Any further questions? I think that's it. Thank you very much.
All right. So again, we're going to be able to hang out here for about another hour. Of course, you're welcome to leave anytime else if you have, but if you choose to hang around until like